In this tutorial, we're going to be creating a very simple light function material. Now, light functions can be used for a wide range of different effects, most of them being environmentally driven. I have personally used light functions for things such as generating fake water caustics on a wall near a pond or some type of water source. They could also be used for something a bit more complex. For instance, if you had a window and rain was drizzling down it, how would you project that shadow onto a surface? Well, one of the ways is doing it through light function materials. Now, unlike most light function materials, I actually like to build mine more so in world coordinates. Now, the reason that I like to do this is because if I have multiple light function sources within a room, I would like them to seamlessly blend together. Mapping them within UV coordinates can actually cause seams if those lights intersect each other. However, if we build it in world coordinates, then it doesn't matter the position of the light because both of them are sharing the same coordinate system and therefore will seamlessly tile. Now you'll notice that I've made a lighting folder under my materials folder. In here, we're going to right-click and create a new material. We'll call this Matte WLF Master. To start this off, we're going to create a world position node. Now what I want to do is I want to multiply this by a small number. Here, I'm going to multiply it by 0.01. Next, I want to isolate just the red and green channels. So we'll do that by creating a component mask. If we right-click and we preview this node, then we're able to see the representation of those coordinates. Let's go ahead and shift these just a bit. We'll do this by adding a value of -1. Since this is going to be driven in a sine node, then what we need to do is we need to add time to the equation. So we'll simply create an add node, and I'm going to create a time node. Now what we could do is we could just plug the time node into the add node, and then plug our other add node into this add node. However, then we could not control the speed at which the time plays. Therefore, let's add in a multiplier and multiply this by a constant vector value. I'm going to put this to 0.2. Last but not least, let's create a sine node. And we'll plug our add node into our sine node. And we'll start previewing this node on the mesh. We've now successfully created a very nice and simple animation. Let's go ahead and break it up just a bit more by adding some noise animation to this. We'll go back to our content browser, and here, locate the textures folder. We'll type in noise, and here I'm going to use this T_tile noise texture. If we double click it, we can see what it looks like. Make sure it's a tileable texture. And with it selected, let's hold down Control and click C to copy the name. We'll then simply add a texture sample, and if it's already selected in the content browser, it'll automatically show up. If not, you can simply click on the drop-down, paste in the name of that tile texture, and click Enter. Now, since we've built this system within the world coordinates, we also want to build the texture information in world coordinates. Therefore, we're going to convert these UVs to world coordinate space. We'll go ahead and utilize the same world position node. We'll grab a hold of our multiply and our scalar value, click Ctrl+C, Ctrl+V, and now I'm going to modify this scalar value to 0.004. Once again, I'm going to create a component mask to mask out the R and G channels, and simply drag this into our texture. The next thing that we want to do is we want to add one more texture element, but this one is actually going to be animated. Let's copy our texture sample, and here I want to create a panner by holding down P and left-clicking. I'll set my X speed to 0.1 and my Y speed to 0.1. With that done, we want to now combine these. We will now multiply both of the green channels together. Finally, we want to combine this add node with this multiply node. The way that we're going to do that is simply create another add node, plug in the multiply into the B input, and plug the first add node into the A input, and drop the output into the sine input. Now what you'll see is we have our normal R and G sine wave information, but on top of that, our texture information is actually warping that previous information that was input into the sine node. Let's add a desaturation node. And plug our final output into the emissive channel. Now one thing that I'm going to do is I'm going to hide all of the connectors. What this will do is it'll collapse down all options that we're not using. And now I'll just clean this up a bit. For the last thing, we're going to set the material up so that it'll work with light functions. We'll simply come to the material domain and change the surface to light function. We'll click the check mark and apply button. Go back to our materials lighting folder and create a new material instance. Let's go ahead and create a new light in our scene. I'll go up to my lights, and I want to choose point light. I'm going to turn off my cast static shadow option here. And then type in light function. We'll now see the light function drop-down menu, and here we can choose a light function to add. Let's click the drop-down, paste in the material name, click enter, and automatically we'll now see that light function on the floor, and on the walls, and anything else that it projects against. The nice thing about this is, when we move the light, remember that we built this effect in world coordinates. This means that if I created another light next to it, you would automatically see that they seamlessly blend together. This is a very big advantage, especially with effects such as water caustics. That seamless blend needs to take place in order for the effect to be properly sold. Now that we have our light function built, we can change things such as the color. Let's make this match the scene just a bit more. If we click play, then we'll see that the light actually projects not only on the surfaces, but also the character and any other objects that are close enough within the radius.